We are going to talk about all kinds of angle relationships inside of circles. First, we're going to review that vertical angles are always congruent. In this diagram, angle 1 and angle 3 are congruent. Angle 4 and angle 2 are congruent. We also want to review that two angles of a linear pair are supplementary. Supplementary means that their measures add to 180 degrees. Angle 5 and angle 6 are a linear pair. They add to 180 degrees. When tangents, secants, and chords intersect within a circle, angles are formed. The relationship between the angle measure and the arc measures vary depending on where the vertex of the angle is located. The vertex might be on the circle, inside the circle, or outside the circle. We're going to look at examples of. If we have a tangent and a chord that intersect at a point on the circle, then their measure of each angle is 1/2 the measure of the intersected arc. Here's a diagram. The measure of angle 1 is 1/2 the measure of its intersected arc. The measure of angle 2 is 1/2 the measure of its intersected arc. Very similar to inscribed angles, when you had two secants that intersect. The measure of this angle is 1/2 the measure of the intercepted arc. If two chords intersect in the interior of a circle, vertical angles are formed. And the measure of each angle is 1/2 the sum of the measures of the intercepted arcs. Here's a diagram. The measure of angle 1 and its vertical angle would equal 1/2 the sum of the intercepted arcs. 1/2 the sum of the intercepted arcs. The same thing is true for angle 2, or its vertical angle. They're congruent. The measure of angle 2 is 1/2 the sum of its intercepted arcs. This is true whether the vertex is at the center of the circle or not at the center of the circle, as long as the vertex is on the interior of the circle. Finally, if a tangent and a secant, or two tangents, or two secants, intersect in the exterior of a circle, outside of the circle, then the measure of each angle formed is 1/2 the difference of the intercepted arcs. 1/2 is a common theme today. So in the first diagram, we have a tangent and a secant. The measure of angle 1 is 1/2 the difference of the arcs. And you're going to always take the large arc minus the small arc. The large arc will always be the one farthest away. In the second diagram, we have two tangents, but the idea is the same. The measure of angle 2 is 1/2 the difference of the two arcs. Notice that those two arcs form a complete circle. And in the third diagram, the measure of angle 3, which is formed by two secants, is 1/2 the measure, 1/2 the difference of the measures of the intercepted arcs. Now let's do some examples. Example 1. Line X is tangent to the circle. Find the measure of arc EFG. Well, we're going to have to use one of the properties we just looked at a little bit backwards. We learned that the measure of the angle, let's call the angle EDG, is half the measure of the arc. We happen to have the measure of the angle, 135 degrees. We're wanting to find the measure of the arc, so we would double the measure of the angle. Multiply both sides by 2. And the measure of arc EFG is 270. Example 2. The value of X would be 1/2 the sum of the intercepted arcs. Well, we'll just call it X. $85 plus 57 is 142. Half of 142, is 71 degrees. The measure of angle Y, trying to get my highlighter in green, would be half the sum of the intercepted arcs. Y is half the sum of the intercepted arcs. 148 plus 70 is 218. And half of 218 is 109 degrees. Let's label our diagram. 109 degrees and 71 degrees. X and Y form a linear pair, so they should add up to 180 since they're supplementary. Quick way to check. Looks like I have good answers. Example 3. Find the value of X. That's right in here. This time the vertex is outside of the circle, so we will take half the difference of the arcs. $115 minus 25 is 90. Half of 90 is 45. Example 4. Measure of angle 4. Example 4. Determine the measure of arc AB. That's right here. And the measure of angle 1. Oh my goodness, we've got some work to do here. We need the measure of arc AB before we can find the measure of angle 1. We have these arc measures. So the measure of arc AB would be the entire circle minus the given arcs. 360 minus 104 minus 111 minus 104 again is 41 degrees. Now that we know the measure of both intersected arcs, we can find the measure of angle 1. The measure of angle 1 would be half the difference of the intersected arcs. 111 minus 41 is 70, and half of 70 is 35. Example 5. A tangent and a chord intersect to form a 75-degree angle. What is the measure of the major arc formed by the chord? AB is the chord. This is the major arc. There are two ways we could do this. We could first find the measure of arc BD. That's going to be double the angle measure, or 150 degrees. And then to find the measure of arc ACB, we could subtract from 360 to get 210 degrees. Or maybe instead you noticed that we have a linear pair. These angles form a linear pair. So we could have said 180 minus 75 to get an angle measure of 105 degrees. And then the measure of arc ACB is double the measure of the angle. Either way, we get 210 degrees. It just depends what you think of first. We have one more example. Determine the value of x. This one's thinking a little bit more outside of the box. We have two tangents. We know this angle. The concept we would use is that the measure of the angle, ADB, would be 1/2 the measure of arc ACB minus the measure of arc AB. But we're going to have to use this formula a little bit backwards. We happen to know the measure of the angle. And we happen to know the measure of the arc AB. We might think we don't know enough information when actually we do. This arc and this arc form a circle. So the major arc that I need is actually 360 degrees minus x. And now we have an equation we can solve for x. I'm going to multiply both sides of my equation by 2. That eliminates the fraction on the right. I will combine my two x's, 104 minus 360 and then divide by -2. Your turn to practice. It takes practice to keep all of these formulas straight for the appropriate situation.